welcome to another Unity 5 tutorial where I'm going to show you how to create a very simple procedural city. So this is a method that allows you to generate a city in 3 dimensions based on just the code. Okay, so it's very similar to the way that the Minecraft tutorials were created in building up procedural landscapes. Okay, so let's start by creating a 3D world. As you can see here, I've already got one, and I've got a plane in that world, and that plane I've scaled out to 1000 in the X and 1000 in the Z. I've put a tarmac asphalt type texture on that surface, and you'll notice that it's positioned in the Y at 0. Now it's important that we have the ground plane at 0 because all of our house models that we're going to include will be sitting on top of this ground, and so everything will be relative to the 0 point. Okay, so I've also imported some assets called Urban Buildings Pack, which you can find in the asset store for free, and it has 5 different buildings in it, all with level of details on them. So if you're not familiar with level of detail, what it does, I'll just drag one of these out into the scene, is that it gives you a different mesh for that particular object based on how far away you are from it. So you can see that as we zoom out, we get different levels of detail on that particular model. Now, we're not going into LODs at the moment, but it is something that you can add as a component onto your object so that the further away the camera is from the object, the lower poly model gets generated, which means that you can actually have quite a large map where the things that are farthest away from the camera are very low poly, and then at some point, if you go far enough out, it will be completely culled so that you can't see it. Now, to hide that culling, you could put fog in your scene as well. All right, so enough about LODs. Let's get rid of that building. Right, so to begin with, we're going to create a empty game object, and we will call it City Manager. And that's going to have our code that's generating our city. So create a new C# file and call it build city. And inside that code, I've already got some starting lines here for you to build. So we first of all have an array of buildings that we're going to give to the script, and then we set a map width and a map height as well. Now, when you're starting out with this, you want to set these values quite low because if you have like a map that's 2000 by 2000, it's going to take a long time to generate it. And while you're still testing it, it's good to have it quite small. 20 by 20 seems to work quite well. And it does give you a decent size map. Now, inside of the start function, we're going to have a nested loop that loops around the height and the width of the map. And in each grid location of that map, it's going to instantiate one of the buildings at random from the list that we give it up here. So with that saved, just flick back into Unity and drag and drop that build city script onto the city manager. Now, once it's attached itself, you can select City Manager, and in the inspector, you'll find the buildings array. Now, we've got 5 different buildings that we're going to select from based on that asset pack that I brought in. And you can use just simple cubes of different shapes and colors for these if you want during this stage. But what I'm going to do is populate this array of buildings now with the prefabs from that Urban Buildings Pack that I brought in, and I will just put them in the order that they're named. If you're using this actual pack, you'll notice that there is a mesh version and also a prefab version of the building, and what we're wanting to put into our array is the actual prefab. So make sure you select the prefab and not the mesh model at this point. Right, okay, so that's our script. Our map width and height still 20 by 20, and we have 5 buildings. Now let's run this and see what we get. So if I press play, it's going to generate a building for each position in the map, which is 20 by 20, and you can see them all here appear in the hierarchy. And here's our little city that we generated. It looks quite small. If I just zoom in on it, and I'll just double click on a building to get over there, and then move out, you can see that we've created this very tightly packed little city of random buildings. Okay, so the grid references that we're working on are 0, 1, 2, 3, 4. So we're just taking the unit size as being the actual position where we're going to put down a building. Now, the buildings that you use won't necessarily be 1 by 1 by 1 in size. So we need to make some kind of consideration in placing these buildings on the map. And we'll call that the actual footprint of the building itself, and use that to sort of spread the buildings out. So back in our script, let's add an integer to the top, and let's call it building. And I'm going to set that to 3. So it'll be a multiplier that we use for spacing out our buildings. Now this building footprint, we want to copy that there and multiply it by the X position and also by the Z position where we're putting the buildings, always making sure that we're putting them at 0 so that they're on that ground plane. Right, so save that and switch back to Unity and run. And now you can see that the buildings are better spaced apart. So if you were to put a first-person controller or a vehicle of some kind down on this map, you can actually see that there are gaps that you could walk through or drive through. If you want them to be more tightly packed together, you can play around with that footprint. We'll just leave it at 3 for now because it gives us a fairly decent sized type of cityscape. Now, if you consider what a city looks like, it's not a random hodgepodge of buildings like we've got here. There's more of a structure and flow to the city itself. Let's just have a look at a real city. Now, I've got a picture here of the Gold Coast in Australia. This is where I live. Not here. This is Surfers Paradise, which is where all the big buildings are. I'm kind of over in the background over here somewhere. But the point I want you to see in this picture is that cities don't have random buildings of random sizes, and you can see a kind of ebb and flow going on in this diagram where you have like a cluster of high rises here and there's another cluster there, and further down the coastline you can see other little clusters, and then you get shorter and smaller areas. And you know, this is because of the purpose of the building. So people like live here, and then you might have some commercial stuff, then you'll have tourist stuff, you know, and all that. So you end up with this kind of smooth pattern of heights running through your entire cityscape. It doesn't just have random high rises here and there. So to create this sort of look in our city, we need to come up with an algorithm that's going to give us some kind of wave formation through the city that will dictate which building heights are where. And essentially it will cluster similar types of buildings together so that you have like the high ones together and the short ones together, but not just in little clumps, but sort of somehow randomly, but more an organized randomness. Now, in computer science, we call that particular type of algorithm generating noise. And you have a noise that is purely random, like you'd see static on the old analog television screens. Or you can have a smooth noise. And one algorithm that's already built into Unity is Perlin noise. And I've spoken about Perlin noise before in the Minecraft series. We're going to use Perlin noise in this case to actually dictate the size of the buildings at certain locations around the city. The Perlin noise function that we'll look at in a moment generates values between 0 and 1. And how you interpret those values depends on what you're actually doing with it. So if we were to actually use the values of 0 and 1 to generate an image, we would get something like this. And this looks like clouds. If you're used to Photoshop, you might have used a filter called difference clouds. Then it creates this type of an image using the Perlin noise algorithm, where 0 is the black areas and 1 is the white areas. So if you were to think that you were looking down on a landscape, in this case, the black areas would be the lower areas and the white areas would be the hilly areas. And this map, which has a whole bunch of coordinates based on the X and the Z, are going to dictate what value the Perlin noise algorithm returns. So you give it a coordinate out of this map and it returns a value. And you can see that it's not random black and white images like a complete mess of noise or static. It's actually a ebb and flow, a wave type format going through here, where you're going from like here is black and it goes up through the grays to whites and then it comes back down again. So you can imagine this as the type of topography for a landscape. We're going to use a similar topography type thing like this, but instead of putting a landscape down, we're going to use the values to determine which building we will actually put in that area. So you could think of it as different types of demographic zones within your particular city. All right, so enough of the theory. Let's start using the Perlin noise algorithm. So back in the code, just open that up. You can see I've already made the changes that you will need to do. And we've still got the vector 3 creating the position for the building, using the building footprint to space them apart. But the additions to this are this first line, which uses the Perlin noise function. And we give the Perlin noise function the width and the height position on our map. So we're actually looping through each position of the height and each position of the width. And for each one of those, we're generating a Perlin noise value that you can see here. Now, Perlin noise will return a value between 0 and 1. And I'm actually multiplying it by 10 and making it an integer so that we get values between 0 and 10, which is fine. Just makes it look a little easier, and it's nicer to work with integers than to work with floats. Okay, so once we've created this Perlin noise value, we're going to use it to determine which building goes where. And you can see that I've put an if-else statement here that says if the result of a Perlin noise is less than 2, then we're going to put building 0. If it's less than 4, we'll put building 1. If it's less than 6, we'll put building 2. If it's less than 8, we'll put building 3. And if it's less than 10, we'll put building 4. Okay, so once you've typed that in, save it. Now let's just go back to Unity and run. Right, so when we run, we can't see any particular difference in our city. In fact, we've got, if I'm correct, every single house is exactly the same. Now, from that, we can conclude that the Perlin noise function for all of those W and H values that we're using is returning exactly the same value each time. And in fact, it is. When we put large values or large differences of values into the Perlin noise, we actually skip over a lot of the detail and you can end up with very, very little variety. So let's just demonstrate by going back into the code. And what I'm going to do is now make these W and H values smaller by dividing them both by 10. So divide by 10.0f, make it a float, and save that. Right, now when we run it, we'll actually see more variety in our city, and you can see that you're getting the similar pattern as I showed you in those clouds before, where you've got clusters of buildings in different areas of the city of different types, which marries up with the way that real cities are. So in similar areas around the city, you have similar types of architecture and similar heights within the city. Now, if we divide by an even bigger value, we can actually then lose definition as well. So if I put 50 in here as our dividing value and save it and run that, okay, you can see now that we've got a very large patch of all the same height buildings, and then we have this small little cluster over here. So by making those W and H values, the inputs to the Perlin noise, smaller and smaller, we're actually picking up more and more detail in the actual map. So let me just show you that. I'll go back to my cloud thing. When we had the big values, it was like picking this point, this point, this point, this point, and this point. And so you're skipping over all the detail of the values from Perlin noise that's going on in here. Now, when we divided by 10, we got something that might have ranged like across here, so that we got a fair bit of, decent variety going on in our Perlin noise. And then when we divided it by the 50, we ended up getting like this small little portion here, which had like a big flat area and then maybe just a little bit of detail on the edge. So what you divide your values by in Perlin noise will depend, will work out the outcome that you see on your map. Okay, so if we just stop playing that, so at about size, what do we have, 10, if I put 20, we might get some more decent detail in there. So it's just a matter of playing around with this and determining what you want. If you had a really massive map, so if you bring this out to 200 by 200, you might want larger areas that are exactly the same, in which case you would be dividing by greater values here. So with 20, okay, we're going to end up with this sort of a configuration going on. Now, I think I prefer it when it was at 10, which gave us a good overview of the detail. So let's just run this again. At 10, okay, so you can see what it looks like there. You've got this sort of high-rise patch sort of flowing through, and then another patch over there, another patch there. Now, if I stop this and run it again, we get exactly the same city going on. Perlin noise is mathematically infinite, so it's this very, very long string of values, and when you call on Perlin noise to get a value out of it, then you can actually start in the same place each time, or you can start at a different place in that string. Now, if you start at the same place each time, you get the same sequence of Perlin noise values. And that's how Minecraft actually works as far as their maps going. They have what's called a seed value, and by using the same seed value, it allows you to create exactly the same map because of the way these numbers are generated. If you want a different map every time you run this, then you can put a seed value into Unity as well. Back in the code, we'll create a seed value. So let's put that in the start function, and we will create a float seed, and let's make that equal random dot range, a value between, say, 0 and 100. And what we'll then do is add that seed to our Perlin noise input values. So we can put plus seed on the first argument, and then plus seed on the next one. And that basically offsets where you're starting to read Perlin noise values from. Okay, so let's save that, and back in Unity we'll run it. And now see that we have a different configuration in this city, and if we run it again, we will get another configuration. Now, if you're wanting to work with the same city over and over again, you can actually set that seed value to be some kind of exact value. So like if you want to have 42 and then just comment that out later, save that, and then run it, you're going to get the exact same city each time, which is a nice way of saving different city maps that are generated like that. Okay, just to finish up with this particular part of this tutorial, I'm going to also add in some grassy areas into our environment. So what I've done previously is to create a cube. I just bring this in here. And what I've done with this cube, so this is just a default Unity cube that I've added with 3D object cube, and I've called it grass, and I've resized it to scale 2 in the X, 0.1 in the Y, and 2 in the Z. And that gives us a nice sort of flat grassy area. And I've also put a seamless grass texture on it as well. And we're going to use this particular cube or flattened cube as some park area in our city. Okay, so let's just remove it out of the hierarchy, but make sure that you drag it once you've created it into assets to make it into a prefab. Right, so to use that in the code, let's go to our city manager. And now the size of the buildings, we'll set that to 6. That will create an extra element on the end of our array of buildings, but we're going to put the last one as the grass in there. Now, inside of the script, we need to deal with this last element. So what I'm going to do here is just add another else if statement right to the end and make the last building that's being instantiated the 5th one, which is our grass. And it's going to be for less than 10. Now we need to change all of these other numbers going down here so that we get a good chance of getting some grassy areas. So let's just work backwards. Let's go 8, 7, 6, 4, 2. That might do it there. You can just play around with these values at the cutoff points of which building you get when ever. So let's save it. Go back to Unity and run. And let me just zoom out so we can see if we got any grassy areas in this case. Now this is going to depend on the particular seed value as well as your cutoff points that you've got here. So if you want grass, let's try and put this down. 6, 5. And I'm going to put this random seed back in again so that we can keep trying it out and save that. Also, you might want to actually put in a debug.log to print out what the value of the seed is, because then when you do find a map that you particularly like to work with, you could hard code it straight into here and then just keep using that particular map. Okay, so there's a city now that we've generated, and you can see that in this city we've got a nice big parkland going on over here. Now, if you want these grassy areas to sort of meet up or become a bit larger, it's easy enough to go to your prefab for your grass and maybe scale it out instead of 2 to scale it out to 3. And then just run that again. Okay, we've got it on random, so we're going to get a different map each time. Find our grassy area, which is now over here. So there's not much grass in that particular seed. No, there's a bit more, but you can see now that the grassy area now all matches up with itself just because we changed the size of that actual cube. Okay, so that's creating your buildings and random buildings for different locations. Now you can play around with the different cutoff points for each particular building. You can add different types of buildings. It's totally up to you what you do with that code. So it's quite flexible. And then you can also generate quite a large map. So what I'll do just right at the end now is just let's make a really big map. So let's go out to, let's say 200 by 200 and run this, which might take a little while. Oh no, not too bad. Okay, now you can see we've actually got a really large city, and you can see the the level of detail working on those buildings as well. And it's happening on the buildings and not on the cubed grass area because we didn't put a level of detail on there. That's why if you zoom out, the buildings will start to disappear, but we still have all of this grass. Okay, so now we have quite a vast city with different architectural areas that you can play around with. So in the next video, I will show you how to put some streets into your city.